Alright, this video is going to cover parent functions, which in our pre-cal book is section 1.6. We're going to be going over 8 parent functions, and I feel like most of this should probably be a review for you coming from Algebra 2. There may be a couple that you didn't deal with. The first one we're going to talk about is the constant function. This is the most basic, and it's just y equals any number. We'll call C for constant. Okay, so just to give you an example, we'll choose a value. Let's say y equals 4. And remember, any constant that's y equals is just going to cross the y-axis at this number. So at 4 would be your y-intercept. Okay, there is no x, so there is no slope. Okay, it's a slope of 0. So then you can just draw your horizontal line through 4. And it would have arrows on both ends. It would go on forever. Okay? The next one we're going to talk about is our identity function. Some of you probably know it as the linear function. And that is our other pretty basic one. And it's just y equals x. Okay, there's no y-intercept here. Y'all are used to seeing equations a lot of times, your linear equations in mx plus b, where this was your slope and this was your y-intercept. Notice we have no number here, so it's an understood 1, so slope of 1, and no number added or subtracted, so it crosses at 0. So your linear function or your identity function goes through the origin with a slope of 1. So you can plot several points and draw your line. Don't forget arrows on both ends. Alright, good. Next up is our quadratic function. You dealt with this a lot in Algebra 2. And that is your x squared. Y equals x squared is the parent function. Okay, and remember there's a couple of ways that people go about graphing this, okay, just because people think in different ways. Most people, I don't know, maybe not most, they may not have to write it out, but you're picturing this chart in your head. You're asking, okay, if I square this value, what do I get? Okay, so let's just start with -2 and go to +2. Okay, to give us a few values on the negatives at 0 and then the positives. Okay, everybody knows that, or should know that we go through the origin, because 0 squared is 0. That's going to be the vertex of our quadratic, and this, remember, is a parabola. Okay, so any number squared is going to come out to be positive. So -2 squared is just +4. -1 squared, +1. 1 squared, +1. 2 squared, +4. Okay, so I can go 1, 1, -1, 1, 2, 4, or -2, 4, and graph my parabola. Arrows on both ends. And remember, you have this axis of symmetry that cuts it down the center, and all points on one side should reflect to the other. Alright, parent function number 4 is our absolute value function. Hopefully everybody remembers what the absolute value symbols look like. Okay, they're the ones that look like the bars on either side. There's those straight lines. Okay. Now remember, absolute value literally means the distance from 0 on a number line. So here, if you want to make yourself this little t-chart to get some values, if you don't remember what the parent function looks like, let's do the same thing again. Let's get a negative, a 0, and a positive. Okay? The distance from 0 on the number line, when I say that, how far is -1 from 0? Just how many units? It's 1 unit. Okay? Positive. 0 is 0 units from 0. 1 is 1 unit from 0. Okay, I'm trying to put it in terms of units so you realize these values are always going to be positive. It doesn't matter if the x is negative or positive, the y is always going to be positive. So we start at 0, 0, 1, 1. Negative 1, 1. Okay, 2's distance from 0 is 2. Negative 2's distance is 2. Okay, so it's going to create this V shape. Okay, these are straight lines. And that would continue forever in both directions. All right, the fifth parent function we're going to cover is the square root function. Okay, square root function is y equals square root of x. Again, I'll make a t-chart for those who like that visual. All right, I'm not going to put all values here. I'm going to only put the ones we know are perfect squares. Okay, so 0 square root is 0. 1 square root is 1. 4 square root is 2. 9 square root is 3. Okay, so this will get us started. Now, you notice I didn't put any negatives. That gets us into imaginary numbers, and we can't graph imaginary numbers. So there are going to be no values negative for x or y. So start at 0, 0, 1, 1, 4, 2, 9, 3. Okay, and so it is curved. This is not a straight line. And has an arrow. It continues on forever in the positive direction. All right, up next is our cubic function. That is y equals x to the power of 3, or x cubed. I think you probably did some work with these in Algebra 2. Not positive, though. All right, so let's take a few values, positive and negative. I'll just go negative 2 through positive 2. Okay, remember when you're cubing a number, you're actually multiplying that number by itself 3 times. Okay, so this is negative 2 times negative 2 times negative 2. Okay, notice negative, negative, negative. That's going to give you a negative. 2 times 2 times 2 is 8. Okay, do the same thing for these others, and you get negative 1, 0, 1, and positive 8. Okay, so let's plot those points and see what shape this gives us. So we go 1, 1, and 2, 8, negative 1, negative 1, negative 2, negative 8. Okay, so this starts in your quadrant 1, goes through the origin and down into quadrant 3. So it's going to be this curve here, and this would have arrows on the ends as well. And this would continue on. It looks like it's almost going straight up, but it is not. It is slightly getting wider and wider and wider. Okay, just very slowly. The seventh parent function we're looking at is the greatest integer function, also known as the step function. And I don't think you will have seen this one before. The equation looks like this. These symbols stand for greatest integer. So y is the greatest integer of x. Okay, it's just like a bracket with an extra line is how you would draw that. Now, what that actually means, sometimes this one's a little harder to understand. It means that your output, your y, is only going to be integers. Okay, remember integers are your counting numbers. Okay, they can be positive or negative, but there's not going to be any decimals. It's just the integers. So I can input any value. I can input decimals, but I'll always get an output of an integer. So I'm going to make you a table over here. Okay, I'm going to input a couple of whole numbers or integers to show you, but I'm also going to input some decimals to explain. So if I put like 0.7, 0.999, Okay, so like I said, output is always going to be an integer, and it is the previous integer. Okay, it's not necessarily what it's closest to. Like you may think that 0.99999 is closest to 1, so you would put 1, but you are putting the previous integer that came before it. So everything between 0 and 1 is just 0. Okay, once you get to 1, you can move on to the integer 1. Everything between 1 and 2 is the integer 1. And then once you get to 2, you can have the integer 2. Okay, and it just keeps repeating that way. So what that looks like on your graph, so you have a point at 0, 0, 1, 1, 2, 2, 3, 3, so on and so forth, same in the negatives. Okay, so it kind of looks like when you're starting this, it looks like the identity function or the linear function, slope of 1, but we do not just connect these points because the output is never a decimal, it's only integers. So that means when I go to input a value at, say, 0.7, I'm still here at 0. At 9.999, I'm still at 0. All of these values, I'm still at 0, so there's going to be a line here until I get to 1. But once I get to 1, it's not 0 anymore, it hops up to 1. So you're going to put an open circle here, and that will continue for all of these. They stay 1 until I get to 2. So open circle, and it jumps up to 2. Stays 2 until I jump up to 3. Okay, and it continues like this in this pattern forever and ever and ever. Okay, so there's your greatest integer function, and you can see why it is also called the step function, because it kind of looks like some steps. Last but not least, our 8th parent function is the rational function, and I know you dealt with this in Algebra 2, so it should look familiar. When you have your variable in the denominator, there's going to be holes or asymptotes, something missing in your graph as far as your domain goes. And we've already done some problems dealing with that. Okay, so let's give you a table of values to look at. You can input, we'll say 0, but you can't actually divide by 0. So when you do 1 divided by 0, your calculator gives you an error, and that's because it's undefined. It's not a real, it doesn't exist. And then if I input 1, 1 divided by 1 is 1. 1 divided by 2 is half. 1 divided by 3 is a third. And notice the larger my input gets, the smaller my output is getting. Okay, what if we put in a smaller input? Let's say I put in half. 1 divided by half, remember dividing by a fraction is the same as multiplying by the reciprocal, so that's really just 1 times 2, and you get 2. Okay, so let's plot these and see what if you can see the shape you're creating. There's no point at 0, that does not exist. We have a point at 1, 1, 2, half, 3, a third, half, 2. And if you went a third, it would go up to 3. Okay, so you have this curve created in quadrant 1, and it's going to continue. You do put arrows on the ends, and notice it's getting closer and closer and closer to the y and x axis, but it will never actually touch. And hopefully you remember that is called an asymptote. So it's never actually going to touch the y or x axis for this parent function. Okay, if we input some negatives, you get the same thing. 1 divided by -1 is -1, so -1, -1. It is all of these points reflected over here. Okay, so -2 would be -half, -3, -third. Okay, so it looks like that same curve in quadrant 3. So there's your parent function for rational.